Hello everyone, in this video we are going to see how for loop works in Python. There is a break statement, continue and pass keywords. These are the keywords we use in for loop. Break, continue, pass. And there is a function called range which is used to create a collection of data. That is used here, and for loop can be nested. The syntax of for loop is like this. For is a keyword, in is a keyword, and there is a variable which will be pointing to elements present in the collection. It will start pointing from one data up to the last data, and there is a body of this for loop, and how many times the body will be run, that depends upon the number of elements present in the collection. So a collection can be a list, a collection can be a string or a tuple, anything it can be, which should be a collection of data. So we will be seeing example programs like this, counting vowels, prime or not, finding prime in a range. We'll code and see. So first of all, for syntax, for I in, okay. So I is a variable for this, so we'll just have for x in, x is a variable. So if you want to point it to string, say for example ABCD, I'm just printing something like this. Okay, hello, I'm printing hello. How many times it will be printed, you just have to see. It prints hello 4 times. So x is pointing to A, then B, then C, then D. 4 characters are present in the string. So that many times the loop will run. So as I told you, how many characters present in the collection matters, or how many elements present in the collection matters. String is a collection, it has character elements. So how many characters are present, that matters. So that many times the loop runs. So it runs 4 times. So in this case, so if I have EF, there are 6 characters, it runs 6 times here. 1, 2, 3, 4, 5, 6 times it runs. So I can use x value also. If I just display x, you will see where x is pointing to. See, x points to A, then B, then C, then D. So it starts from the A, then go into the body, it prints, then it points to B, then it goes into the body. So likewise it finally points to F, then it goes into the body, then it prints, then it comes out. That's it. So when it comes out of the loop, if you just print x, it will be printing this F, which is lastly printed. You see, it prints A, B, C, D, E, F, okay, up to this one. Then it is printing this F, which is outside. So outside of the loop, yes, whatever the x pointing lastly will be still there. So you can use that, make use of that if you want. And this is pointing of the strings. So here there is a function called range, where you can use that one to generate collection of numbers, you can say integers. So range is a function. So here it works as in like slicing the strings. So if I say first initially with 110, so if you are giving only one argument, the default the number range starts from 0 and it goes up to this number you are given -1. So it just goes up to 0 to 9. So if I print and see, it prints 0 to 9. So why this 9 is printed outside? This is outside the loop because of this print. Okay, so it prints from 0 and it goes up to 9. So 0 to 9, and outside it is still carrying that what is the last value it is printing, it is using that one, so that it is printing. So there are some other range arguments types. So if I give a number, say for example 3, so it starts from 3 and it goes up to 9. So in this case, if you see how it's printing, so 0 to 9 in the default case, but in the case where I'm giving the start, it will go from the start. Say we are giving the start as 3, so it is starting from 3, it goes up to 9. 3, 4, 5, 6, 7, 8, 9 will be printed. Okay, so if I started from say minus 3 to 9 will be printed. So minus 3 and then minus 2, 1, minus 1 up to 9 will be printed. Okay, so the default increment value is plus 1. So plus means the third argument can be increment value. So if I say 2, increment is 2. So it starts from minus 3, goes up to 9, but it increments 2. So minus 3, after that it will comes minus 1. It will not print minus 2. So now that's a collection. You are just going through this collection. This collection can be, so it starts from minus 3, then it's going to minus 1, because minus 3 plus 2 is minus 1. Minus 1 plus 2, the step, that is 1. 1 plus 2, 3. 3 plus 2, 5. Then 9. Then 7. Then 9. So it will not jump across 11. So it will not jump. Okay. So even if I give 11, it will not print 11. It will go up to 10. Go up to 10. So the thing is, maximum is it can go up to 10. What it is printing? It prints up to 9. So minus 3 onwards it starts. Minus 3 onwards it starts. Then minus 1, then plus 2, then plus 2, then plus 2, then plus 2, then plus 2. If you do plus 2, it will just cross or reach my 11. So it cannot reach 11. So the last ending number should not be reached. It can go up to before that number. So that is 10 only I can go, up to 10 only I can go, but 10 will not come here because this range is 2. So you should understand this range. But there are different ways. So if I give, say for example, here I am giving 1 to 11, that means it prints up to 1 to 10. But if I give minus 1, so that means you are trying to get into reverse thing. Okay, you are starting from minus 1. So if you apply the step, it will never go towards 11. 1 minus 1, 0. 1 plus minus 1 is 0. Then it goes towards the left side of 1 in the number line, not the right side, because ours is right side. 1 to 11 is the number line right side, but you are trying to get into left side because it's negative. So here it will, range is empty. It will not print anything. It will not print anything. Range is empty. So but if it is plus 1, then it is fine. Okay. But if I go from 11 to 1, so in this case 11 to 1 I have to go. So it's actually going to left of the numbers in the number line. 11 to 1 is the left side it goes. So 11 minus 1, 10, 10 minus 1, 9. So there is a possibility of going from this number to this number because it's a minus step. So this is fine. So here how it will print, here it starts from 11, but it will not touch 1. It will go up to 0. You just see it printing, how it prints. It will go touch up to sorry, 2. Because if you have numbers like this, say if you say the number listing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we are starting from 11, minus 1 it goes. As I told you, it will not touch this one, it just go on before that, previous to that, penultimate. So it will reach 2, up to 2 only it goes. Okay. So you see again, it starts from 11 and it goes up to 2. So if I just put it like minus 3, where it will go? It will go up to minus 2. So 0, then minus 1, then minus 2, then minus 3. So where it should reach minus 3, it should end. But before this ending, we are coming from right side to left side. It reaches the penultimate. Penultimate is minus 2. So in this case, it reaches up to minus 2. You see, minus 2. If I give a step, that's also fine. So if I give a step of 2, it starts from 11, then 9, then 7, then 5, it goes, and then it has to go up to minus 3. So before this, it has to end. It can go up till minus 2. But minus 2 will not be coming in this series if you are doing step of 2. So it will reach up to minus 1. Reach up to minus 1. So this is a collection. You can create number collection like this, and you can use this one. Use these numbers here. Okay. So that's the use of range function. And as I told you, if I give this one without any body, it will throw error. Okay. So if I want to put something without a body, I can use this keyword pass keyword. Here there is nothing will happen, no error. Okay. So pass keyword is used when you are writing a for loop, and if you don't want any body to be there, you can use a pass keyword for that. So this is a usage of for loop with number collection and string. So it can be list and it can be tuples also. I can use it many ways, but we'll just show some examples using this for range. Say for example, I want to find a number is prime or not. Say if I have a number 49, I want to find whether it is prime or not. So here I can run for divisors. Divisors range from 2. Okay, 2 up to, say for example, div limit. I can just say where the divisor should go. Num / 2. So give a quotient. So till that place I can reach. So div limit. Div limit plus 1. That means it will go up to div limit. 2 to div limit. So div is a divisor. So now if I check if a num percentile divisor is equal to 0, that means it's not going to be a prime. So in this case, just print not prime, it's a composite, and then I will break keyword usage. So for example, 49 will not be divided by 2, 3, 4, 5 now, but it will be divided by 7. When it's divided with remainder 0, we have to break out. No need to continue with dividing with 8 or 9, 10 like that. So we break out of the loop and then we just say print. It's not a prime, we are just printing here. It's a composite way of printing. It's a composite number. But in this outside case, if I give say 47, which is a prime number, in this case we will never come into if body. So I can just say print prime. Okay. But in the case of composite, like 49, it will come here. Outside I will print prime, that's a problem. So we'll just set up flag equal to 1, and then we'll put a flag here initially, that is f equal to 0. So based on the flag only I can check if f is still 0, that means it never hit into if body. So then in that case it's a prime. So this will do our job. So what we are doing here, we are having a number, we are going to find whether this number is prime or not. So we are just finding a range of divisors. The divisor starts from 2 and it goes all the way up to half of the number. So one by one we are dividing the divisors. With the divisor 2 we are dividing, then with the 3 we are going. So that it creates a range. There is no need to increment and all. It automatically does this. So it starts with 2. Then it does not divide, it's to go to 3, then 4, then 5. Likewise it goes up to half of this number. But meanwhile, if some number divides it with a remainder 0, then we have to just stop and break out. That's what we are doing here. So in this case we'll just range you just have to give the keyword div in range. Okay, so it prints composite. So if I give 47, it should be printing prime. Okay, so this way we can use the range function to generate a list of divisors, and we are just going. And if I want to show one more example with a string, here I can just comment out this whole thing. So say for example, if I want to find vowels, presence of vowels in a string, say for example I'll have a string like this, st is, say for example we'll have India, that's a string. In this string do you have vowel or not? Say for I in st, so I will point to one by one. First will point to I, then N, then D, then I, then A, like this. So for example, we'll just go with one other thing where there is, say we'll just say trial. Trial is the one. So first I points to T, then it points to R. It's not a vowel. Then it points to I. It's a vowel. It has to come out. So it's a program is about whether vowel is present or not. So first your I is pointing to element by element in this string ST. So for each I, we are going to run a loop. It's a inner loop. So here J in, okay, J in A E I O U. So for each I, J will run for 5 times. So if I is equal to J, then I can just say it's having a vowel. So in this case, I can just say prints vowel present. I can just break out. So the same way as in prime, we just have to come out with one flag. So initially I have f equal to 0, then I just put f equal to 1 here, the same logic. So in this case we are just coming out. From where you are coming out, you just have to see. I equal to j, if it is equal, you are coming out. From where you are coming out, you are coming out of the inner for loop, but you have to come out of the outer for loop also. There is no need to go further because this is I. Okay, so we'll just check it with x. Okay, x is a variable. We are just equating with x is pointing to I here, the third one. Then j will run from A E I O U. So whether this is x is I, when x is pointing to A E I O U, even it hits j hits I, these will be matching. Then I will be setting it to 1. Then I will be breaking out, but it will break out of the inner form. Then again it will go to I will point to A, but there is no need because your objective is to check whether vowel is present or not. So whenever it comes out of the inner for loop through break or anything, so here in this case if it comes out of break, you just have to check whether f is equal to 1. That means whether it has entered the if. So if it enters the if, then I can just do one thing. We can break out of the outer for also. Okay. So outside I can just say if f is equal to 0, you can just say print no vowel present. Okay. So what you have to understand here is x is pointing to TRAL. So first it points to T, then it enters the body. Now j is pointing to AEIOU. It has to go through 5 times. It will go through A, then E, then I. So this body of this for from line number 17 to 20, it will run 5 times. So j pointing to AEIOU in sequence. So x is pointing to T. So you are trying to check the T with A, then T with E, then T with I, then T with U, then O and U. So you will be checking all these. If it is not at all going into the body, F will be 0 only. So it will not break out. So it just goes again to x. X is pointed to R. The same thing goes for R. It will not be 1. It will be 0 only still. Now x goes to I. X goes to I. Now j will go to this one. So I is equal to A, I to E, I to I. Yeah. I to I is matching. So it prints vowel present. F is made to 1. It breaks. It breaks out of which one? Inner for loop. So it comes out. So that means it's in this place 21, which is in the outer for loop. Now I am checking if f equal to 1. Yes. There is no need to make x to point to A and go further. Because we are just checking whether vowel present or not. I am just breaking out. So for loop breaks out. Outer for loop breaks out. So it comes here. If f equal to 0, we are just saying f is 0. That means it never hit this place. No vowel present. If f equal to 1, we are just giving a message here itself. Okay. So in this case, vowel present. Okay. Vowel present. What vowel present if you want to display? I can just display this vowel present, comma, you just say j, that j, whatever the j is pointing to, it will be present. I is present. I is the first one it founds. A is also present, but the first one it will come out. Okay, so if I give some other value, you can just say MNPQR. So in this case there is no vowel present here, no vowel present. Okay, if I say O here, M1PQRO, it's just vowel present. O is the vowel. Okay, so this way we can use vowel finding, and here you see inner for loop presence. Okay, if you want to see how this goes again, you just see this one. This is the outer X. So for here you see I'm just print X and a J I'll print. So you see what it goes. ST equal to say ABCDE. So here you see how this works. So when X is A, J runs from A, E, I, O, U. Okay. So we are just pointing to X is A. Okay. X is A. This is a full output. X is A, J is A, X is A, J is E, X is A, J is I, X is A, then J is O, X is A, J is U. Then J loop finished. X goes here. Now X points to B. Now again J starts. J is A, J is E, likewise it goes. Okay. So one thing you have to understand in for loop is, even if you change something here, say for example, here it goes to A, B, C, D, E, F, like this. If you have, say for example, this is the thing. If you are making, say print X, I'm doing here, I'm just changing X to A again. If I say A, every time I'm changing to A. Okay. So if I print X again, we see, I'll just keep only 4 letters, A, B, C, D. So X is pointed to A, it prints A. Then I am pointed to A, it prints A. No problem. No problem. Okay. So after that it goes. I made X equal to A, but here I am pointing to X equal to B. It prints B. I am making again X equal to A. It prints A here. But when it goes here, it will be pointing to C only. So you cannot break this pointing of this collection. When X started to point from A to D, whatever you do with X, it will not affect it. But it will affect here because I am making it to A. When I am printing X here, it will print A only here. But when it goes to the loop, this 14th line, what is the last time it pointed? It will go to the next one and it will point there. You just see the code. So first it is printing. What it is printing first? You see, it prints A because X is A. Now we are making to X is A, then printing A, second A is printed. Now it goes here. Now we don't think that X is A, then it's still A now. So X is B now. Okay, B is printed. Now X is A, it prints A. Okay, it prints A here, but it will not start again with A, or it won't go to B. No, it will go to C only because already B is pointed. You go to C, C is printed, again A is printed, then as D is printed, you are making it. So you cannot just whatever the value you are assigning here, it will not break that collection pointing. That's what you have to remember here. Okay. So in this prime number finding, if you want to find prime in range, say for example, I just want to print all the primes between 100, okay, and 200. Say left boundary, I have a right boundary is 200. From 100 to 200, from to 2. So this is from, and this is 2. I want to print all the primes present in this range. So what we can do, we can simply do one thing. We can just, this is a logic of finding prime. And what I'm going to do, we'll just run a loop here, outer loop for I, or in range starting from 100 to 200, 2 at 1. That means we'll go up to 200. Step is by default plus 1, unless you give it its default is +1. So that means it starts from 100, goes up to 200. This is I. This is I. Or I can just say a num, because I'm using num here inside. So a number starts from 100, it goes up to this outer loop, outer for. So when it goes inside, I'm setting a do limit num y by 2. So inside first 100, the limit is f0, everything is happening here. So I just need to print that number. What are the prime numbers? If it is divided, it's not composite. So if it is dividing, then don't need to print composite and all. And we just break out. Okay, we just break out. If you are making f equal to 1, then when it is f equal to 0, that means it never got here. So in the printing of prime, what I can do, I can just print the number. What's the number you are working with? You are working with num. So I can print that num. So it's very simple. See, outer loop starts from 100. So first it takes 100, works for 100. Okay, when the whole thing is finished, it goes again 101. It 101 by 2. So if something happens here, it changes to 1 and everything is going as per the last time how we discussed for prime number. Just I added this range 100 to 201. Let us see how it works. So it prints all the numbers which are prime from 100 to 200. So 101, 103, 107, 109, all these are prime numbers. So we are printing prime numbers present in the range. So you can see the use of for loops, nested for loops, one for loop inside another for loop. You can see. So we have seen break usage, we have seen pass usage, and there is a continue usage. When there is a continue, what's a continue? You just have to see. Say for example, we take an example of finding. If you want to find the GCD, where you can use continue, you can see use of continue in GCD finding. So GCD finding, we can use for loop for GCD finding. First, what's a GCD? We just get two numbers. We just need to find a greatest common divisor. That's called GCD. So we just go the raw way. We're not worrying about optimized way, recursion functions, nothing. We just find a GCD of two numbers in a raw way. So for example, I have number A. Okay, say number A is 44. Say number B I have, which is 22. Okay, so the greatest common divisor here is 22. Okay, but if I have number 33, let us imagine the greatest common divisor is 11. Okay, so if I have 22 here, the greatest common divisor is B, number B itself, because B divides A without any reminder. The whole number quotient I am getting. So what you have to do, first you have to find the biggest number, and then you have to use the smallest number as divisor start. You have to start dividing both numbers with the smallest number. So first we just if A greater than B, okay, then we just say S equal to small equal to B, okay, else S equal to A. Here it finds the smallest. Okay, now we're going to start the divisor range. So for div in range, the divisors will start ranging from small number up to which one always divides. So smallest number to 1, it's in the reverse way. Okay, -1. So for example, here 22 is the smallest. S is 22. So range starts from 22 and goes all the way to 1. So it should be in the negative, because 22 minus 1, 21. Then 21 minus 1, 20. Likewise, only I can reach 1. So minus is a proper one. So range is a proper one. So this is a divisor range. So divisor range starts from 22 and goes all the way up to 1. If something divides in between from the 22 to 1, we will just stop it and we will just say it's the greatest, because we are already going from descending order. So that will be the greatest if something divides in that range. So here, if A, number A, okay, divided by divisor is equal to 0, gives or a percentile divisor equal to 0. If both numbers are divided by the divisor without any remainder, that means, friends, you just say GCD is that number. The divisor is, that's the GCD. Else what we have to do is just to continue. Okay. Else we can just say continue. So here, if it is dividing, then we are just printing the GCD and we can break out. Else we can just say continue, but in this case there is no need for continue. Anyhow it will just go, because there is no body after that. There is no need for continue. Okay. So print the GCD and then it just, so it's one more example for usage of a for loop. So in this case, if you execute, it should print 22. So if I say it's 11, if I say 12, if I say 12, the greatest common divisor in this case is 11. Why the 11 is coming here? Oh, sorry, this should be B. Okay, sorry, it should be B. So 12 here. Okay, 12 to 0. A is 44, then we got 12, A is 44, then smallest is B here, divisor start from smallest, in this case B, 12 is the divisor, we are dividing number A by 12, that will not give a 0, we just have to put AND, sorry about this, both should, okay, AND, sorry about this. So GCD is 4. So in this case only 4 will divide the things. Okay. So if it is 33, it is 11. 11 is the divisor. It will divide. 11 divides both. The greatest common divisor. If it is 22, 22 divides both. Okay. So and okay. So you start from 22, go up to 1. A should be divided by the divisor and gives the remainder 0, and both should be divided, so not or. Okay. So this is one example for break. Say for example, if I am having a range like this, say for I in range 1 to 100. Okay. So if I am just have to what you can say, if I just have to sum the numbers, or I just have to print the numbers which are I can say which are divided by say 3 and or 7, let us say. You just have to find out which are the numbers which are divided by 3 and 7. Okay, that number should be printed from 1 to 1000. Okay, 1000 means 1001, I would just say. So what's the objective? We just have to print numbers divided by 1 and thousands. Print numbers divided by 1 and 7. Sorry, 3 and 7. Sorry, 3 and 7. Okay. So here, if I is divided by 3 without a remainder, and I divided by 7 without a remainder. Okay, then we just have to just print it. In this case, say, let us see how this goes. Print, let's say print I. How many will be coming? I in range. Sorry, these are all numbers which are divided by 3 and 7. Okay, so like this we can make use of a lot of things very easy by using for loop. Okay, and regarding the continue, say for example I have for I in range 1 comma 100 1000. Okay, 1 comma 100 I have. Say for example if I equal to 5, okay, or if I is equal to 55, only these two cases. Imagine I don't want to do anything else, I'll just say print else I say print I. Okay, so in this case I don't want to print, means I just say continue. Okay, do not do anything else, otherwise you print. Okay, otherwise I just say print I. So this is the body of the if. So if I equal to 5 or if I equal to 55, don't do anything, you just continue. Continue means continue with the loop. Okay, continue means continue with the loop, just go to the loop running. Fine. So here you'll just print without this 55 and 5. You see, there will not be any 55, 54 and then 56. So in that case it went into loops, and the 5 will also be not there. You see, 4 and 5, 4 and 6, 5 is not there. So if it is equal to 5 equal to 55, I am just putting a keyword continue. That means go to the loop. That's it. So whenever it hits in the body of for loop, whenever it gets a continue, say for example I have many things, I have many lines like this, I have many lines like this. So if there is a continue here, okay, the body started to run. In the second line continuous hit means the line number 4, 5, 6 will not be run. That's the idea. Continue will directly take you to the for loops range finding. That the range, if you go with range. Okay, so that's the usage of continue. So we have seen the usage of break, continue, pass, and the range functions used in for loop. Okay, so I hope this video is useful to you. Thank you for listening.